Hi guys, this is Ms. Martinez, and in this video we are finding the equations of tangent lines. So your objectives as a student are going to be to apply the properties of derivatives to find the equation of a tangent line at a point. So we're going to get to use the properties that you saw in the last lesson and find the equation of a tangent line at specific points. So I want to clarify something and remind you that the derivative of f at the value x is given by this equation. And that function, f prime, it in itself isn't the equation of the tangent line. It is just the slope of the tangent line to the graph of f at a point. So when you find the derivative, you're only finding the slope. And in this video, in this section, we're not only going to find the slope, we're going to find the equation of that tangent line. So let's get started with our first example. You are looking at the equation and the graph that corresponds to it. And we want to find the derivative of that parabolic function. Well, the derivative, we would use our properties. Y prime would be 2x minus 1. You're using your power property, the power rule, I should say, and the constant rule to find those derivatives, to find that derivative, I should say. Now, that was part A. Part B, let's find the point on the curve where x is 1. So where is it 1? What is the y value when your x is 1? Well, you would substitute that in, and that would be 1 minus 1, which is 0. So that would be -2 at that x value of 1. So that gives us that little coordinate there. All right, so that is the point that we are concerned with. Now let's find the slope of the tangent line at that specific point. So what we'll do is we'll plug in the x value into our general derivative, which was 2x minus 1. And so that gives us a slope of 1 because 2 minus 1 is 1. So the slope of the tangent line at that point is 1. But we want the equation. So how would we go about finding the equation of the tangent line? Well, we know the slope and we know the point, a point, and so we'll use point-slope form. We'll substitute in the point, the y value, and the x value, as well as our slope, simplify, and solve for y. Now we can very easily graph that line. It goes through -3 and has a slope of +1, and that is the equation y equals x minus 3. That is the equation of the tangent line at that point. Now, it'll change depending on what point you're working with, but for this specific point on this specific graph, that would be the equation of the tangent line. All right, so let's look at something a little different here. Let's find the equation of the line tangent to this graph, this cubic graph, at x equaling -1. So the first thing we want to do is we want to find the slope of the line, the slope of our tangent line, which is found using the derivative. So the derivative of our f function, f prime, is 12x squared minus 5. And we are concerned with the x value of -1. So we'll plug that in to find the slope at that value, at that point. And that will give us 7. So the slope of our tangent line at -1 is 7. Now that we have slope, we need a point on this line to be able to give the linear equation tangent to our curve. All right, so we're concerned with our function at -1. So we're going to substitute -1 into our f equation to find the y value at that point. So that would be -4 plus 5 plus 3. That is 4 when simplified. So the coordinate that we're going through on our cubic graph is -1, 4. We know that the slope of our tangent line is 7, so we'll plug those values into our point slope form. And simplify. And solve. And that would be the equation of the line tangent to this cubic graph at -1. All right. Example 3, we're looking at a table to give our responses. We're going to find the equation of the line tangent to our g function at the x value of 6. So we're going to take the same approach. Let's find the slope of the line first. What is the slope of our line at 6? Well, that is the derivative of our g function, and that would be at 6 it is -4. Then we need a point on our graph of our g function. G at 6 is 7. And then we'll plug those values into our equation for our line. We'll plug in the point and the slope. And we'll simplify and solve. That would be the equation of the line tangent to our g function at 6. All right, one more example here that I want to go through. I'm sorry, one more part to this example is now looking at the equation f at that x value of 6. So we go through the same process, and if you want to pause the video and try this on your own, feel free. So the slope of our line when f is 6, that would be the derivative, and that is 2. The point at when f is 6, that's going to be -3. That is a point on our line. And now we'll plug those in to find the equation of our line. Plugging in the y value, the x value, and the slope. Simplifying and solving. And that would be the equation of the line that is tangent to the function f at 6. All right, now this one's slightly different. We want to find the equation of the line tangent to the graph f at the point where the slope of the derivative, or the slope of the, I should say, tangent line is 2. We're going to round all our values to 3 decimal places. Okay, so how is this different? Well, we already know what slope we're working with, what we're trying to find. We're not given the x value that we are concerned with. We're trying to actually find that. We want to find the x value where the slope of the tangent line is 2. Okay, so the derivative of this equation would be 4x cubed plus 4x. And the slope that we are working with, we don't know the x value, but we do know that the slope of our equation is 2. So how do we go about finding the x value and finding the y value, the points on this line? Well, we're going to work with a system of equations. And we're going to find the intersection where this happens. We're going to find where the derivative intersects the line y equals 2. And you can do this graphically, because if you just plugged in the 2 in there, it would be very hard to solve. So we are searching for the intersection, and that will give us the x value where the derivative intersects the equation where the slope is 2. So graphically it looks something like this when you graph those two. And you can see the intersection, but it's not a nice integer value. And your calculator has a wonderful function. If you press the calculate button, second calc, if you scroll down, you'll see there's an option for intersect. And if you go through that process, selecting the first curve and the second curve, making sure that it has selected both graphs, the result, your screen will say something like this, and it'll tell you where that intersection occurs. The intersection occurs at the x value of 0.4238. And what we need to do is on the original graph, not the derivative, but on that original quartic graph, what would be the output? And you would plug that into the original f function, and that result would be 0.3916. And like we've been doing now, you plug in the x, the y, and your desired slope. You simplify and solve, and that would be the final equation of the line tangent to our graph where that slope is 2. All right, I know there's one more example, but I want you guys to try that one on your own, and we will go through it together when we meet again. Thanks.